Okay, good day, guys. I thought we have class today, okay, but actually today is Dr. Faiz's class, so I will just record a very simple and straightforward Adme lectures, okay, because I believe you already did your assignments and you already know what is adsorption, distribution, metabolism, and excretion is. Okay, for the review and forward, the toxicity of substance always depends on the dose, okay, based on the Paracelsus, the father of toxicology. But ultimately, it's not the dose but the concentration of toxicant at the site of action that determines the toxicity. Okay? Sometimes we call this as the ultimate toxicant. The concentration of a chemical at the site of action depends on ADME or toxicokinetics. Okay, because ADME sometimes we refer to the pharmacokinetics. Okay, but like I said to you many times, pharmaco and toxicokinetics are similar, just the substrate is different, and also the impact lah. The toxicokinetics will give toxic impact, whereby the pharmacokinetics will give the drug effect. Okay, actually in class I want to show you two of these videos about the ADME, okay, because ADME you can find a lot of different videos, very interactive. Okay, but I guess because this is a recording, you can watch this video by yourself. Okay, so pharmacokinetics or toxicokinetics basically involve, the first one is absorption, okay, based on the 4 or 5 different absorption that you learn in the secondary school, okay, which is the passive diffusion, ferristatic diffusion, endocytosis, and also against the concentration gradient, active transport. Okay? Secondly, the metabolism, okay, which usually happens in the liver, but can also happens to certain degree during the absorption in the cell lining of the gut, okay, and also at certain organs. Okay, for example, when you breathe in the toxicant, some of the metabolism already happens in your lung, okay, instead of the liver. Okay, and then distribution, okay, distribution to different tissues, and finally excretion that usually happens in urine and feces. The one that happens in the urine is usually low molecular in weight, okay, and they are very water soluble, but the feces usually happens for a bigger or larger molecular weight of the toxicant or the drugs. Okay, these are some of the illustration of the ADME. This can be a good graphical abstract, okay, because it summarizes everything in the lectures, or in your case, summarize everything in the journal. Okay. So for absorption, okay, very fast, because this one is pretty basic. You learn a lot during your secondary school. Okay, the rate of absorption is actually dependent on the physical chemical properties of the chemical. Is it hydrophobic? Is it hydrophilic? If it is hydrophobic, it can easily pass through the lipid bilayer of the cell. Okay, if it is hydrophilic, it will require some kind of protein to help it go through the hydrophobic layer of the cell. Okay, is it ionized? Is it non-ionized? Is it weak or acid base? Because all of these properties will impact on how it can go through the lipid bilayer. How about the molecular weight? Is it big? If big, it might require different kind of absorption. For example, if the molecule is very big, the cell will need to do endocytosis to take in the chemical into the cell. Okay, is it volatile or not? Second is about the route of exposure. How the chemical enters into the body. Okay, is it through the eating of the chemical, the oral route? Okay, is it through the nose? Okay, as you can see, some drugs need to be taken through the nose. Okay, is it through IV? Okay, if IV, it can go directly into the blood without pass through the liver, therefore it is not being metabolized. Okay. Essentially, getting the chemicals across the cell membrane involve two major mechanism. The first one is diffusion or passive transport, which can also use ferristatic diffusion using protein pore, okay, on the cell wall. Second, the active transport, where ATP is needed to transport certain chemical that is against the concentration gradient. Okay. For the adsorption across a membrane, it says here the membrane is a phospholipid bilayer consisting of polar head group and non-polar tail. So hydrophobic compound can easily pass through the membrane, but the hydrophilic compound, which loves the water but hate the fat, will need some kind of help across the membrane. Okay, in this case, they will need a or certain kind of protein to help them to go through the membrane bilayer of the cell. Type of transport, the first one is a passive diffusion. No ATP is required, but it is gradient driven. If it is against the concentration gradient, you will need the active transport. Okay, this one is very straightforward lah, because you learn during the secondary school, so I will not describe this one further. Okay, facilitated diffusion, of course, using the protein, and active transport using the ATP to transport the molecule from against the concentration gradient. Route of exposure can be many route of exposure depending on how you take the drugs. For example, oral can be the nose, it can be the through direct injection into the blood vessel. Okay, sometimes, especially for babies, we just take the medicine and put them through the what we call it, buttocks, okay, the rectum. So all of this will impact how the drug or toxicant is being absorbed. With acid and bases will be absorbed by simple diffusion, in which they call the most lipid soluble form. In the most lipid soluble form, highly hydrophilic substances may be absorbed through transporters. Okay, synbiotic with similar structure to the endogenous substrate. It may undergo first pass metabolism or pre-systemic elimination in gastric or in liver cell. Okay, like I told you earlier, the metabolism usually happens in the liver, but it can also go through some sort of metabolism in the first place where it is being absorbed. Highly hydrophobic compound, okay, may be absorbed into the lymphatic system via chylomicron. Okay, chylomicron is the lipoproteins, okay, that is being used to transport the lipid soluble compound. Okay, in this case, it is easily passed through the lipid bilayer of the cell, but during the transport to the liver, they need to be transported using chylomicron first in the lymphatic system. Okay, not same as the hydrophilic components, okay, whereby the hydrophilic components, they will be transported directly in the blood straight to the liver. But for the hydrophobic compound, through the lymphatic system first, and then they will enter the blood, and then they enter the liver. The greatest level of absorption for most ingested substances is happening in the small intestine. Okay, the second route of exposure in the lung. Okay, usually the toxicant or the compound that is being absorbed in the lung are gases. Okay, second one is vapor and volatile liquids, and the third one is aerosol. And we also learned last time that certain small substances, for example asbestos, can also be absorbed by the lung, okay, depending on the size of the particle. Okay, example of the toxicant gases or volatile liquid, it can be carbon monoxide that can bind to the hemoglobin much greater than oxygen. Okay, chloroform, sarin gas, okay, some kind of gas that is being used in the chemical warfare. Carbon tetrachloride, okay, that is usually used in the fridge or used as a solvent in the cleaning agent. Okay, and finally benzene, okay, largely found in the crude oil, but also found in tobacco smoke and used in glues, paint, and detergent. So that's why some kids, they take the glue and inhale them to give the effect similar to drugs. They usually can cause cancer. Okay, in this case, leukemia. Okay, next common route of exposure is skin. Okay, because of course our skin is commonly exposed to many kind of toxic agent. Okay, it says here, fortunately, the skin is not very permeable and is a good barrier for separating organisms from their environment. because the cell walls are dead, they are resistant, and they are dry. Okay, so all this toxicant is hard to pass through this skin. Okay, so skin act as a barrier from the toxicant. There are some special route of exposure, for example, injection, okay, under the skin, okay, or into the muscle, or into the peritoneal cavity, or directly into the bloodstream. Okay, and usually the exposure through the injection is much greater. I mean the absorption is much greater through injection compared to the other route of exposure. Okay, route of exposure and physical-chemical properties of xenobiotic determines how a chemical is absorbed and whether it goes through a first-pass metabolism or subjected to systemic circulation. Okay, first-pass metabolism happens at the site of absorption or to some degree in the liver. Okay, before it is subjected to the circulation. If you take injection, so you can bypass this metabolism. The degree of ionization and lipid solubility of chemical are very important for oral and percutaneous exposure. For exposure to aerosol and particle, the size and water solubility are important. This one we learned from last week, okay, before the EAT festival. For dermal absorption, polarity, molecular weight, and carrier solvent of toxicant and hydration of epidermis is important. Okay, next, after absorption, we enter into the second part of Adme, which is distribution. Okay, the important part of distribution, it depends on physical-chemical properties of the chemical. Second, the blood flow. The higher the blood flow is, the greater the distribution. Third is the rate of diffusion out of the capillary bed into the cells of organ or tissue, okay, depending on the organs. And finally, the affinity of xenobiotic for various tissue, okay, because certain xenobiotic or certain drugs, they are more they have greater affinity towards certain part of the tissue or cells, okay, depending on how they bind to the receptor. Okay, the fourth one is actually the toxicodynamics, okay, which we will not cover, but it's great for you to know. Okay, the concept of toxicodynamics, which usually pair very well with toxicokinetics. Distribution can be highly localized, restricted, or wide depending on the first one, binding and dissolution into various storage sites. Okay, whether the depending on the physical chemical of the toxicant. For example, if it is fat soluble, it will usually bind to the fat soluble cell. Okay, or maybe it is being stored in the liver, for example, vitamin A, or maybe it has a high affinity to the bone. Okay, for example, certain toxic mineral, or maybe the methyl mercury. Second is the permeability through membranes, okay, whether it is fat or water soluble. The third one is protein binding, whether it can bind very strongly to certain protein. For example, certain toxicant can bind very strongly to the protein in the blood. Okay, so they can be traveling through the blood, okay, very strongly because they can bind to certain protein in the blood. Fourth, whether they are actively transported into the cell. If the toxicant accumulates at a site away from a toxic site of action, it is considered as a storage depot. Okay, like I said to you before, some of the toxicant can bind very strongly to the protein. For example, the plasma protein in the blood, which is albumin. Okay, it can bind to the very large number of different compounds. For example, bilirubin, calcium, copper, zinc, vitamin C, fatty acids, okay, penicillin, okay, this kind of chemical, barbiturate, histamine, and so on. Bilirubin is a heme byproduct, is neurotoxic at high level, but is normally bound to albumin to make it less toxic. So if your albumin is not functioning well, this bilirubin may be released in the cell and in the blood, causing some kind of toxic to the body. Liver and kidney are also two popular storage depot in the body because they have the highest capacity for binding chemical. Okay, for example, they have high cytoplasmic protein of ligandin and metallothionein, okay, that can have high affinity for certain kind of toxicant or chemical. Fat is also another popular storage depot, especially for lipophilic toxicant. Okay, for example, dioxin, DDT, and polychlorinated biphenyls. Okay, it says here the LD50 of fat stock compound will be higher in obese subject. Okay, means that obese people, they have higher resistance towards this chemical because they can be stored first in this fat tissue. However, a quick weight loss can result in large release of toxicant and toxic effect. Okay, especially if you lost weight very much in a few days, okay, it can release a lot of this toxic chemical at once, okay, and can cause some kind of adverse effect in the body. Okay, finally, bone can also be used as storage depot. Okay, compounds such as fluoride, lead, okay, which can be pretty toxic, and strontium may be incorporated and stored in bone matrix. 90% of lead in the body is eventually found in skeleton, and some scientists can use this one as an indicator on how long the skeleton has been dead or has been buried in the soil, because the lead, the half-life is very long. The mechanism of storage is through exchange of bone component for the toxicant. Okay, for example, fluoride may displace hydroxide. Okay, plumbum may substitute for calcium in the lattice of the matrix of the bone. Okay, one of the example of the metal mercury that we can ingest or consume from food, okay, it shows here it actually can be transported across the blood-brain barrier, which is a very strong barrier for the brain, okay, because metal mercury can combine together with cysteine, one of the amino acid in the body, and form metal mercury cysteine, which is very similar structure to methionine, another amino acid that is common in the body. So this methionine can be transported across the blood-brain barrier and cause the toxic effect in the brain. Okay, these are some of the family of ATP binding cassette proteins. Okay, you don't need to know in detail, but just so you know that this compound or this protein, they are present in the cell and they usually transport the toxicant or the chemical against the concentration gradient out from the cell. Okay, so they reduce the toxicity. But the problem is sometimes they also transport beneficial compound. For example, if you have cancer and you take the medicine or the drug for the cancer, they can also transport the drugs out from the cell, okay, and reduce the effectiveness of the drugs of the medicine. Okay, after the distribution, okay, we enter into the metabolism. The elimination of xenobiotics often depends on their conversion to water-soluble chemical through biotransformation, catalyzed by multiple enzymes. Okay, the most important ones is cytochrome P450. Okay, cytochrome P450 is just the name of a group of thousands of different enzymes in the liver that convert the xenobiotics or the drugs into more lipophilic hydrophilic form, so that it can be excreted in the urine. Okay, it says here biotransformation changes the properties of xenobiotic, usually from a lipophilic form that favors absorption to hydrophilic form, favoring excretion in the urine or bile. Biotransformation can detoxify or bioactivate xenobiotics to more toxic form. Okay, so usually it will detoxify by converting into hydrophilic form, but sometimes it can also activate the xenobiotics or activate the drugs. Okay, for example, if you ever heard about the name of provitamin A, okay, means that provitamin is not activated yet. Okay, once it enters into the liver, it becomes activated form of vitamin A. Okay, I just going to summarize here. I'm not going to tell you in detail, okay, because you already did your assignment. Okay, basically there are two major phases of biotransformation. Okay, but in reality there are actually three phases. But we are going to cover for the first two only, because this first two is the most significant component of the biotransformation. Phase 1 always try to convert into more hydrophilic form of chemical. Okay, means that they are more soluble in water. Phase 2 is about conjugating, means that attaching a big larger group to make it more hydrophilic. Okay, in case the phase 1 is not sufficient enough to make it hydrophilic. Okay, what I'm trying to say is first one they convert to hydrophilic one, but if it's not hydrophilic enough, then it will proceed to phase 2. If it is already hydrophilic enough, it will be excreted at phase 1 already. Okay, if it is not enough, then it will proceed to phase 2, whereby the conjugation of larger molecule that is very hydrophilic will assist in the excretion of the product. Okay, you can read this for yourself. Basically, there are different chemical reaction that happens. For the phase 1 is hydrolysis, redox and redox, okay, to make it more hydrophilic. Second is conjugation, okay, by different kind of chemical, big chemical, to make it more hydrophilic. Okay, this one you can read it yourself, okay, and also based on your assignment. Okay, and usually they are being assisted or being catalyzed by the cytochrome P450, okay, to make it more polar, okay, to make it more hydrophilic. Okay, phase 2 is the conjugation of different product, okay, addition of a larger functional group to make it more hydrophilic. Okay, toxicants can be excreted through several routes. Okay, the two most important one, especially if you take the toxicant or the xenobiotics through the oral or injection, is through the kidney, urine, feces if the molecular weight is big, and if the toxicant is in the form of gas, it can be excreted through the gas as well. As you can see in the picture, alcohol which exists in the gaseous form in the body can be excreted through the lung as well. And as a result, we can detect the alcoholic content in the breath, okay, using the breath analyzer by the police lah, usually. And finally, this is the video on the pharmaco or toxicodynamics, which I will not cover in this lecture, but I hope you can watch it, okay, in order for you to enhance the understanding of the toxicokinetics, okay. Very interesting lah, on how the drug or toxicant can bind to the receptor and cause the changes in the cell, okay, and cause the toxicity. Okay, I think that's all for the lecture today. Okay, please do your assignment, which can help you understand the core components of the kinetics. In my opinion, this is probably the most important principle that you learn in the toxicology. Okay, once you understand this one, you can easily understand the other principle of the toxicology as well. Okay, thank you.